Hello, everyone, and welcome to this NNUG meetup. You might notice that I'm a new face, so hello to you all. I'm Torsten Nicolaisen, and I'm one of the new board members here. Håkan, which is usually on the screen, is helping out behind the scenes today. For those of you that are new to the group, welcome. And to give you a little intro, we are a part of the .NET Foundation, and we're an independent user group that focuses on .NET. And as you can see, we are by developers for developers. And we primarily tend to focus on talks where the presenters have practical experience with the things they are talking about. We're always interested in people that have something interesting to present. So if you have something or you know somebody who has something interested, please contact us on this contact details. And we would also like to thank our sponsors, because without them, it wouldn't be possible to arrange these meetups on a regular interval. So thank you all. So the NNUG board is this group of beautiful people. We are the ones that are organizing these meetups. And please contact us if you have any questions. You'll find us on LinkedIn or Twitter and probably other social media as well. There's also a prize for having the best question today, so don't hesitate to ask questions during the presentation. Microsoft has a swag pack they will be giving away to the winner. And you can also register for a learner's badge at this address from Microsoft if you want that. And today, we have the honor of having Mads Torgersen here to tell us about the future of C#. And I personally I'm looking really forward to this. It's going to be interesting. The agenda is very simple, as you can see. I'm going to let Mads have the floor in a minute. And we are going to have a Q&A after the talk. So you can either ask the question directly, and if possible, we'll try to ask it during the presentation. But if not, we'll ask them afterwards. So then I'll leave the floor to you, Mads.
Well, thank you, and hey, Norge. Yeah, you might be wondering what's with the Torgersen. Yeah, I'm not Norwegian. I'm married to it, but there's definitely history there. We will do this, and if you don't know either, I'm from Denmark, but I think we'll do this in English just to be sure everyone can follow along, and because I probably wouldn't know half the words in Norwegian anyway, Danish for that matter. My day job is I work for Microsoft. I am the lead designer of C#, and work with a group of people to concoct the next set of features for that awesome language. So I'm assuming that, given this is a .NET user group, that a lot of you have had at least a glancing blow with C# in the past. So before we dive into talking about the technical stuff, I just wanted to quickly touch base on how we think about the job of evolving and designing C#. Just while we're here, you should feel free to ask questions. They will come in to Håkan, who will send them to Torstein, who will read them out to me. So I will know when there are questions, and just feel free to ask them anytime along this, or questions or comments. I like getting some feedback, and you can help steer the conversation to where you think it's interesting. I'll make sure also that there's a little bit of time in the end for sort of open questions that don't necessarily relate to exactly what I present, or if you think of them later. So don't hold back. You also want that swag pack. I haven't seen it, but I'm sure it's fantastic. So the C# language strategy is actually, after many years of just winging it, we said, okay, let's write down what is how we think about what's the strategy for each of our three languages. So if you go to that URL there, you can see the C#, the Visual Basic, and the F# language strategy. They're 3 years old, but they pretty much hold up still. That's the point of a strategy, is it's supposed to hold for a while, but I'll just quickly summarize the main points in the C# one here. One is that when it comes to C#, we want to be fairly aggressive about evolving it and innovating in it. So the developer landscape evolves all the time, both in terms of other languages coming up with fancy stuff that we can steal, and also just the challenges you face as developers change significantly over time, and oftentimes in a way that really requires the programming languages to follow along in order to have a good first-class experience, in order to for it to feel natural to address those new challenges. A case in point in C# might be async, which when I started on C#, programming asynchronously was starting to become a thing that people did, but it was still like a niche thing maybe. And then as the cloud exploded and mobile exploded and almost every application essentially became distributed in some fashion, communicating with other devices, all of a sudden asynchrony became central, and it needed to be addressed in the language. So that's an example of that. Essentially, sort of informally, we want C# to be a language you would choose for your next project, not just for your previous or existing ones. So one that addresses the challenges of today, and is not just around because it's legacy code. So we lean into that. We lean into evolution quite a bit. We do want to make sure that when we do evolve C# and add new things to it, we try to benefit all C# developers and not just a small niche. C# is being used for so many things these days. It really has a very broad set of domains where it's being used by quite a number of people. So we want to try to keep that in mind and not accidentally favor a particular subset of that set of people. So many additions to C# are less domain specific and quite general in nature. That's how we try to do it. And then finally, probably one of the places where we've changed the most is that C# has gone over the years. From when I joined 15 years ago, it was designed in secret. There were C# design meetings that happened at Microsoft, and after a couple of years, we would have built what we designed and we would release it onto the world, and hopefully, it was good. And since then, we've moved tremendously. Not just the implementation of C#, the so-called Roslyn compiler is open source now, but also the language design itself. And in both the design and the implementation front, we have a lot of community participation. The dialogue is intense. Like, we have actual contributions. We also have a lot of dialogue, so that we get a quick feedback loop, if you will, of our ideas, and we're able to correct ourselves in real time when we're about to make mistakes, or pick up some of the good ideas that the community brings in. But at the same time, we don't want to become a language that's just everybody's ideas piled together. One of the things that I hear frequently that people love about C# is that it still has a coherent feel. There's still sort of like a spirit of C#, and we want to provide, from the C# language design team, we want to provide a strong leadership, a strong stewardship of the language, so that so features go through this process of being massaged and kind of fitted in to C#. And if we can't do that, we probably won't do the feature. We don't want things sort of hanging off the side, feeling wrong in C#. So the combination of having a broad communication channel, but also having a strong center of leadership and stewardship, that's how we try to govern C#'s evolution, if you want. So I want to see if there are any questions already on this. I think, let me see. As far as I can see in the channel, people are just saying hi. Hi. So, but yeah, get those questions flowing, and let's see what you all have in mind. But you're probably here for this. You're here to see, to talk about what's next for C#. So let's hop out of PowerPoint and into Visual Studio, and let's take the other one first, and let's talk about some of the features that are coming out in C#9, which is scheduled to be out next month. So about a month from now, this will all be yours. And in fact, there are already previews out. They've been out for a while that you can get. Previews of Visual Studio, for instance, where you can enable the preview version of the language and play with these yourself. And this is one of those previews. So let's go and play here. So here I have a program, very simple program that displays, creates an instance of this class and displays it. And one of the trends that has sort of been running through C# evolution over time is it started out, as most programming languages were back then, a few notable exceptions, but most sort of mainstream programming languages were fairly verbose. That's a lot. That's a lot. You say a lot. People didn't mind that so much. But now we've gradually become more aware of sort of the danger of boilerplate. There's so much code just has to be there for some reason, and it's easy to it clutters up your code, makes it harder to see the essential parts, and it also is bug prone because you might do it wrong, like you might do the boilerplate wrong, or you might not keep it up to date with the rest or stuff like that. So we've been on a continuous hunt for places where we can tighten up and just make the code smaller and clearer. And one of the big things is something that we inherited. I think I can safely admit something we inherited from Java is this fact that the main program has to be in a main method that has to be in some class. And that means that if you want to go and look at your sort of the essential code, you have to find this place in your and dig in these two levels of indentation to find the code that really is the program. And that seems so last century. So we would love it if we could simply get rid of this boilerplate, all the wrapping around the main program here. And indeed now in C#9 you can. If we just indent here, you can see that get no squiggles. This is completely valid C#. You can now write your program at the top level, sequence of statements, just at the top level. So your program no longer has to be nested like this. And that just seems clearer. The only reason for me to ever write a main method again is to show that I can get rid of it in a talk like this. You can do exactly the same things. If we even make it so that, because people will be like, okay, what about command line arguments? Well, you can still actually, that's a magic variable just called args. You could say args 0 here, and we would, there we go. Oh, I can't put a semicolon there. Sorry, for some reason, the IntelliSense is a little slow today. Maybe that's because I have an experimental preview. But you can see I can just still access args, and I can do most of the other things that you can do in a program. I just don't have to nest it in that arbitrary group like I'm used to. I want to see if there are any questions on that. You guys are just you're just eating your dinner or something. So here's one. What happens if you make sorry, Torstein, I'm reading it out myself. What happens if you make two such files in the same project? Well, you just get an error. We decided that there's no special magic with this. We can always change that if we want to be smarter at some point. There's no special magic here. Just like if you have main methods in more than one place, you don't have a unique entry point. We just say all your statements have to be in one place. Otherwise, which order would we glue them together in? And your file doesn't have to have a special name. It doesn't have to be called program. It's just whichever file has top-level statements, that's the main program. Questions coming in now. Can it be async? Yes, it can. So just like main can be async, you can have your main program here be implicitly async. And so if you just use a wait in there, wait test.run of something that returns hunter, like this, then we'll just make the entry point async, and that'll work just fine. A question, will this also mean that you support async await in console programs? We already do, actually. We added that in C# 7.1 or something like that, that even for an explicit main program, you can just make it async and return a task or task event, and that will work. But it also works implicitly here at the top level. So yeah, I was demoing async for a couple of releases without being able to have an async main program. That was pretty painful. So we ended up putting it in just for me. No, I think other people find it useful too. I also want to call out that there's a method declaration here, and you might wonder, what does that do when it's at the top level? And we wondered about that too. What should that do? Because some programming languages, they actually allow you to declare methods or functions at the top level, and they can be part of the API directly without being nested in a static class or anything. And we wondered whether we should sort of do that at the same time, but we didn't. So the way that we look at it is that this is just like you have local functions inside of methods. You can declare a function in there. Again, since C# 7 something, I believe. We also let you have local functions in your main program. So this is just a part of the main program, and it's not actually, you can't actually call displayPerson from inside of your class declaration. So if from inside of anything other than the main program, it's actually an error to do so, which means that if sometime later we want to give these the meaning of sort of project level, we might reinterpret this as being an internal project level method. We could enable that later, and we could even let you put public in front, and then it could be part of the API if we want to have top level functions at some point as part of C#. We protected that ability, but we didn't do it because we're not sure it's a good idea. So there you go, top level functions, and great questions. So with that, it doesn't look like there are more questions here. Oh, here was one. Was the drawback considered that instead of knowing about one bit of magic, main, everyone will now need to know about 2 different bits of magic that achieve the same thing? Yes. We always, we know that whenever we add something, we're adding a little bit of complexity to the language. And for people who read code, you now need to know that there are 2 different ways the main program can be specified. And so that's always that kind of hump where you say, okay, this feature adds some, you can sort of tell the history of the language. If we were doing it clean, like starting over, we would just have one of those. We would probably just have the top level functions. And we, in that sense, we regret the main methods and we wouldn't have put them in. But that's something you have to live with, and that's a price to pay. I agree with that. Yeah, that was part of the trade-off. All right, but I do want to. I want you to consider people coming to C# for the first time, or people who don't use it every day, and so on. But even coming to it for the first time, writing your first line of code, having to put all this goop around it before you can write your hello world, that's fairly prohibitive. Like, that's a lot of stuff you have to be able to ignore and say, yeah, I'll learn about that later, just in order to write a line of code that prints something out. Actually, the stuff that is still, in your face in a way, is the usings. And one of the things that we're considering for the future is whether you should be able to have usings defined offline somehow, like outside of the file. Maybe you have shared usings for the whole project that are just always there. That would seem useful. And it means that, you know, your template will probably have some of those already. And again, when you come to C# for the first time, your program could literally be one line. And if you you know, if you have things that you just use across the whole project, you know, it'd just be simpler. You're in context, you know, these things are there. You don't have to see it at the top of every file. That's something we're considering. Okay, so another thing you might notice is that I'm creating my person object using an object initializer. And if you look at the person class, which there's now room for on the screen because we got rid of all that extra goop, you notice that it doesn't have any constructor declaration. That's one of the nice things about using object initializers is that the classes don't have to have to have constructors. You don't have to deal with all the constructor chaining and in particular in a hierarchy, you know, the constructor parameter list can get kind of long, and your code gets a little brittle when you change something. We add a new member, you have to remember to get everything updated just right. And so object initializers have always, or since we added them, they've been a good alternative. Sometimes you want constructors, sometimes you want object initializers. And the cases for object initializers are many, you know, so a lot of people enjoy them, and I've heard of companies that actually mandate them. They say you have to use object initializers for object creation because constructors are too brittle. There's too high of a chance of breaking things when you use them. So we like object initializers. It's a good alternative. However, they rely strongly on the object being mutable, because what happens is that the default constructor gets called first here, and then the object initializer gets executed in the form of assignments to the properties or fields that are mentioned in there. And so if we were to go, if we were interested in making an immutable model, and that's one of the things that is becoming more and more common and popular, is you want immutable object models. Now we start getting errors that we can't assign to these properties because they're getter only. So what do we do? The answer that we came up with in C#9 was, well, what if there was a way that you could have a setter that only works in an object initializer? We call an initter. And an init accessor here allows you, it's the same as a setter, except that it can't be used after the object initializer. So if I were to go and try to change the last name here of the person dot last, wow, this is slow, person dot last name equals, let's take another Scott on the team. Then as soon as things settle here, we get a red squiggle saying, hey, now you can't assign it. So the init is really a set that's limited to the object initializer. And it's not just for auto properties. You can define your own init accessor as well. And it's the same thing. It's instead of a setter, and it does the same thing, but only during initialization times. It gives you this time where you can initialize the object, and then at the end of the object initializer, those members with the initter, they sort of seal off. The compiler won't let you assign to those members anymore. So this is good for now. You don't have to leave your objects vulnerable to accidental mutation after they're created, if that's not your intention. You can specify the intention that they can be initialized through an object initializer, and then they're fixed. They're immutable. So that's init only. Any questions on that? Okay. So, well, thank you. So then there's a question of, okay, so immutable objects are great. But how do you change them? So what if something changes? And that in the so people use immutable objects for various reasons, or immutable data. But typically, when you do use immutable data to describe an evolving state, then the way to think of it is that you sort of have a top-level state that evolves, the state of the world, if you will, and that's an immutable data structure. And then whenever something changes, you create a new version of the world that can be in a big or on a bigger or a smaller scale. If, for instance, you look at our Roslyn compiler, we actually have a full public API for the C# language that you can get the syntax trees and all the semantic information for a piece of C# code. Like the same compiler technology that we use to build the C# compiler is available as an API in C#, and that represents C# code with an immutable object model as well, like exactly like this. And so the way you mutate it is what we call non-destructive mutation. You have a series of methods and so on that will give you the same thing but with something changed. And this gives you the ability. First of all, immutability helps you with concurrency. You never have shared mutable state problems if you don't have mutable state. And it also is great for things like being able to represent both the before and after, for logging, for diffing, that kind of stuff. But the non-destructive mutation, like how do you actually do that? Typically, you adorn your immutable object with a bunch of helper methods that are called with this, with that gives you back a new object. But that's cumbersome. So could we do something at the language level to help with that? And the answer is yes, we can. The thing to help with that is what we call records. Instead of declaring something as a class, you can declare it as a record. And a record is it's a class still, but it's a special kind of class that has some superpowers. It has some additional features on it that are about treating the object more as a value, more defined in terms of its contents, rather than as something with a strong identity and a state. And so it gives you the possibility, it gives you a couple of things that on the object. The first of which is that it supports non-destructive mutation now through a new expression form called a with expression. So let's actually use it here. So non-destructive mutation means we don't want to be able to change the person object, but we want to create another person from the first person with something's changed. So the way you do that is you say person with, and then you simply put an object initializer. There can be more than one property in here. The idea is you get essentially, think of it as you get a copy of the person, and then this initialization gets applied on top of that copy. And that leads to a new object, the other person. So if we display the person and we display the other person, we have two persons that are similar in every regard, except where we explicitly change them in the with expression. So
actually, I've got a question here for you.
Yeah, go for it.
So there's a question. Is it possible to have either an init or a set? Sorry. The question is it? It's actually a statement and a question at once here. So, is it possible to have both an init or a set at the same time? Can you have both of them, or is it like one only?
It's one only. Think of it, the init as it is the setter, but with a special restriction on it. So you can only have one of them. You can't have one that gets used in initializer and another one that gets used after that for remaining mutation. That was a design choice. We had that design choice before us, and we were like, that's just too confusing. Let's just, and we couldn't really think of many good scenarios for it. So let's just say that you can only have one setter, and it's either called set or init, and that's the way it works. Okay, there's one more question. As far as I heard, you can still abuse the init setters with reflection like we can private setters today. Thoughts on that? Yeah, there's a limit as to how much we can protect you from reflection. You can also actually use reflection to abuse reflection to set read-only fields today, for instance. We're not able to protect you all the way into the runtime. These things are enforced by the compiler. So there are places where you sort of, if you want to use reflection, you can run off the rails a little bit. Now we're getting questions that have to do with the with expression. How are the objects copied? And that's a great question, because again, this is something that we struggle with a lot. We chose not to use member-wise clone, and instead we put some extra logic into we generate some extra members inside of the record to do the copying. And the way that works is there's a virtual method with a secret name that only the compiler can say, like a name you can't say in C#. There's a virtual method in a record that gets overridden in derived records, because we want the copy to make a full clone. Like the resulting object should have the same runtime type and the same values, even of data that the compiler doesn't know that were there at the point where you do the with expression. And so there's a virtual method that takes care of that. And the way it does it is it calls a constructor that we also generate. There's a protected constructor in there that's a copy constructor. Takes in the old object and initializes the new one from it. And it copies things shallowly, so it's very close to what member-wise clone would do. It's not much different. But actually, if you really want to fine-tune your copy semantics, you can actually declare that copy constructor yourself. You could go and say protected person original, and then you could actually define a copy constructor and say, this is how I want the object copied. That's very advanced, and most people won't want to do that. But that's just to explain how it works under the hood. Is the with optimized away into a field mutation if the old object is never reused? No, because we can't track that in general, and we don't want to be that smart. No, it's not. There's a copy, and you pay for it. Now, if the garbage collector might be smart about this and realize that fairly quickly that there's no reference left to the old object, and it'll take it away. But there is a copy that happens. Okay. So let me see. Let's try to compile and run this to make the point about how this works. And there you go. There are two objects next to each other. It's got Hunter and it's got Hanselman. When you see those diffs, like when you use a refactoring in Visual Studio, that's actually a similar thing, right? That's the diff between two versions of the syntax tree before and after a non-destructive mutation. So it's very useful. Now, so I said that records give you this ability to participate in a with expression and in non-destructive mutation. But the other sort of value-oriented thing that records do is that they give you value equality by default. So instead of equality by, instead of objects being equal just because their references are the same, they're the same object, we will automatically implement value equality for you on a record so that if you compare things equal, they will be equal as long as all the fields inside compare equal. Similar to how a struct works, actually. So if we want to see that in action, we can say var original person equals other person, and then with the name changed back. Last name equals Hunter. So that should give us an object that has the same value as the original one, but a different object identity. And so if we go and Right line some things here. Let's say equals of person and original person. Then that should give us true, whereas if we do a reference comparison, we should see that there's indeed a new object, because yeah, we don't try to reuse them and be smart. Equals, we go. Okay, so let's try and get this correctly. We should be able to see that they're indeed now equal, even though they're references, even though they're two different objects. And again, one of the challenges with value equality is making sure that it's right, even when you have hierarchies. I don't have a hierarchy here, but if you have object hierarchies, you want to make sure that the equality is still symmetric, right? You might have a person and a student, which derives from person, and if you compare them one way, if you're not careful, then the person will say, well, this student is equal to me because all the person things in the student are the same. Whereas the student will say, well, this person is not equal to me because I'm a student and they're not. And so you don't want this asymmetry. And we have tricks in how we generate the equality. We make sure that the equality is symmetric. Essentially, records are only equal when they're the same record type. Here's a question about, in your example, how many copies of the string Scott are on the heap? 2 records, or 1 because structural sharing? I think the string Scott will only be there once. And it's actually not, that the string is not copied. It's a shallow copy, so we just do ordinary assignment the next level down, if you will. Okay, so that's sort of like the core of what records do. They give you value behavior in terms of non-destructive mutation and value-based equality. There's a question about whether structurally typed records are a consideration, or they will always be nominally typed. We are, so for people who wonder what's the difference, the difference is nominal typing is when you have to have the same declared type in order to be interchangeable, like assignable to one another. Whereas structural typing, as long as you have the right shape, like the same members with the same types recursively, then you could fit another type that has the same shape. For instance, TypeScript is structurally typed. It's all about what you have inside and not the type that happened to be declared. And that's come up from time to time. Should we have structural typing in C#? And either sort of in general, or specifically maybe for things like records, have a kind of types that are structural. And we decided not to, because we think it's not as useful as people sometimes think it is. It's kind of what you have to do when you have an underlying language. Like TypeScript has an underlying language, JavaScript, that just doesn't have classes at runtime. The types don't exist at runtime. And now you have to put something on top that's structural. But we haven't found it to be particularly useful. The situations where you happen to have two types that are the same without already having coordinated are really like probably not very common. There would always be some difference that would mean that they wouldn't match up anyway, because you happen to do things a little differently. And so that's not a reliable way of decoupling or achieving some sort of like independence. And in fact, if you plan for things, you have to plan for things to match up. It's better to put that plan into the code somehow and create a nominal relationship so that it gets maintained as the code evolves. So for those reasons, we haven't really been attracted to structural types. Is there any interesting way to find out what value changed between records? That's a great question. It's not a built-in way. You would have to build that essentially the diffing logic yourself. You could certainly imagine having a virtual diff method. That's actually an interesting idea. You could imagine having a virtual diff method that is like the equals method that goes through and compares everything, but it would somehow give you, it would tell you everything that changed. What about serialization? Do existing serializers need to be updated to support records? So records really are just classes. They have some special magic in them on top of what normal classes do. We're actually in C# 10, we're trying to see if we can take the little bits that are truly magic and make them normal language, implement them in terms, add new language features to implement them in terms of, so that records become less special. But either way, today they're just objects. They have fields and properties and everything. They implement classes, or they are instances of classes. And so you should be able to use them the same way from a serialization perspective. There's one more thing I want to show you about records, which is that in records, we are pioneering a feature that is planned to come to all classes and structs in C# 10, which is what we call primary constructors. But only records have them in C# 9. Now, C# 10 is planned to only be a year out. So if you want them for the whole thing, just a little more patience and they'll get there. But the idea with a primary constructor is that rather than declaring so for people who do want to declare constructors, which we haven't so far, but if you do want to declare constructors, you typically end up having a lot of boilerplate, just, having both the parameters and the members and the assignment between them and all that stuff. And be nice if it was simpler. So we, with records, we let you declare parameters directly on the class name. If you're inheriting from something, you could even declare arguments to the base as well. So if let's say that object took arguments, we could pass first name here, just like we were doing a base call in a constructor. Obviously, object doesn't have a constructor like that, but just to show it to you. So primary constructors are this idea that you can put your constructor parameters directly on the class, and then they're in scope inside of the class. So I could do equals first name here and equals last name here. And you see it even works if the parameter names and the member names are the same. We make sure that the scoping works out so that this first name here binds to the parameter. As you can see, they light up together in the IDE, not to the member here. Now, that's how primary constructors are going to work for every type in the future. For records specifically, they do some extra things. The primary constructors do some extra things. They essentially, in a record, the primary constructor parameters you can only have primary constructor parameters that also have a corresponding member of the same name, like this. So this is legal. If I changed one of the names here, it's still legal, because what happens is that, or if I remove it, it's still legal, because what happens is that we generate a property for you from any primary constructor parameters that don't have a corresponding property. We will generate one for you. So we see, is there something called first name? No. Then we generate one. Whereas there is a last name, so here we won't generate another one. So that allows you to abbreviate your records to a large degree, because you can remove all these member declarations as long as you like the properties we generate for you. So what do we generate? We generate exactly this. We generate public init-only auto properties that are then initialized to the parameter that comes in. So that way we could also remove this one, and we're getting exactly the same meaning as you had before. You have this 2-argument constructor, and we could actually even put a semicolon instead of the curlies. And we get the public init-only properties generated for us. So that's a very terse way if you want to also have a 2-argument constructor. Let's see. I think that's what I wanted to say about records. I have one more C#9 feature I wanted to demo, and then we can talk a little bit more about what else is on the horizon. All right. Just want to see if anything comes in on this before I have to switch to another file. I'll switch. So let's go to this one. So another thing that sort of a feature set that's been evolving over the past couple of releases in C# is pattern matching. We used to not have pattern matching at all. Since C#7, in C#7 we introduced the notion of pattern matching, and then we've been expanding it and refining it ever since. So here's an example of pattern matching that you can also go and play with. It's in the tutorial on docs.microsoft.com. The tutorial for pattern matching has this exact example, so you can go play with it yourself. This is sort of pattern matching at the C#8 state that is currently shown here, and I'm going to use some C#9 stuff in here. So if you're not used to, if this is sort of very modern C#, so some of you your eyes might like pop out here, but let's take a deep breath and dive in and see what happens here. So here's it's an expression-bodied method here. It's a method that takes in a parameter, and then the whole body of it is one expression. So that's why it has the arrow here. Okay, that expression is a switch expression, which we also added in C#8. And switch expressions are like switch statements, except they're expressions and they have a slightly different syntax, but the same overall idea. And so I switch on the vehicle, and then I have a bunch of cases in here. This is one case. This line here is one case. This is one case, and so on. So a case is a pattern followed by one of these fat arrows here. And so we just check the pattern against the value of the vehicle that comes in until we find a pattern that matches. Now, there are a couple of things that are like, there's one thing that's a little annoying in C#8, which is that when you want to just match against the type, you still have to say, with the discard that you don't care about the actual object. You just want to know that it's a taxi in this case. So now you can remove that discard. You don't have to say that you don't care. You can just not care. So that's a small improvement, but just want to mention it. More interestingly, there are a couple of new patterns that are very useful. So you see that there's a couple of cases here where I have a when clause that applies some Boolean logic that involves comparison to constants. Now, this comparison to constants can actually now be expressed as its own kind of pattern. So there's a pattern that means greater than 5,000. So let's try to use that. And the way we do it is we take the delivery truck T, and then we create a nested, instead of having 3 cases with delivery trucks, we make a nested switch for those 3 cases. So we take a delivery truck T, and then we apply a pattern to its gross weight class. Switch curly. And now, let's see. And now you see that that first line here, it has no squiggles because it's a legal pattern case here. It has or a switch case. It has the pattern greater than 5,000, and then it has an expression for the result if that pattern matches. So all we have to do is to finish up the switch here. We can just do this one as a discard for now, and an end curly, a comma, and a little bit of indentation. That red squiggle should go away. There we go. And now we have created a nested pattern that takes that int here, if it's greater than 5,000, then this is the result. If it's less than 3,000, then this is the result. And otherwise, this is the result. Right. So this is relational patterns, we call them. Compared to a constant, that is now a pattern. So something is a little annoying here still, which is these are kind of out of order in terms of the order of where the intervals are. And that's so that we can have this catch-all at the end that's in between. But wouldn't it be nice if I could give both an upper and a lower limit in the same pattern? In fact, it would be nice if I could combine any two patterns into one pattern. And so that's what we have logical patterns for. We have AND patterns, OR patterns, and NOT patterns as well in C#9. So I could say this instead as it's greater than or equal to 3,000, and it's less than or equal to 5,000, like this. So the AND here combines these two patterns, which could be any patterns, combines them together and creates a pattern that's satisfied if they both are. So this means the same thing, which means we can go and take that first line and move it down to the end. So now the patterns come in the right order, sort of numerically speaking. Now I am I'm looking to see if somebody's going to ask the question. Not yet. Let's give it a little more time. That's a question you probably might want to ask. I mentioned that there are also OR and NOT patterns. So here's an example where we could use the NOT null pattern, for instance, where null is a pattern. It's a constant pattern that checks against null. And not null means checking that something is not null. That's a pattern that was sort of missing in the up until now, a way to explicitly say, I want to match anything that's not null. So there you go. There you have that. So why use keywords? And oh, that's a great question. I'll come to that in a second. So why use keywords and not the usual double ampersand and so on in C#? The answer to that is that would be massively ambiguous in a number of cases. Like there are so many patterns that have expressions inside and expressions that have patterns inside through the is expression and so on, that we would never be able to tell when the double ampersand applies to two patterns or when it applies to the expressions inside or the expressions on the outside. If we could come up with a rule, that would be a breaking change for existing code and so on. So we're just like, we can never do this if we want to use the same syntax. So then we have two choices. Should we never do this, or should we have a different syntax? And we looked at this for a bit and we're like, that's not so bad. That's actually fine. And maybe it's good that the syntax is a little more different from the expressions inside of the pattern. So it's easy to tell that this is, this separates the patterns. So we said, okay, we'll go with words. It's the AND word, it's the NOT word, it's the OR word instead of glyphs for the logic here. Now, Eivind asks if we check that patterns are exhaustive. Yes, we do. So let's try it out. Let's say that we only match up to 4,000 here. Let's see what happens. Wait a bit, because for some reason my Visual Studio is super slow today. There we go. There's a warning here that says, not only does it say that we don't handle all possible values of the input type, it's not exhaustive, we also give an example of a value that's not handled. In this case, 4001. So the compiler is trying to be very smart about this and if possible, give you an actual value that is not covered. On the other hand, I can change this back. Let's say that we forgot this bit. Now, there's another problem in here, which is that the last case is unreachable, and that's actually an error. You can't have a case that's unreachable. The compiler can see that between these two, it's handled all the cases. There's no number that's greater than 5,000, but not greater than or equal to 3,000. And so it will actually give you an error here. So we both check reachability, which is an error if you fail it, and we check exhaustiveness, which is a warning. What happens if you ignore the warning is that we will throw an exception at the end of the switch. If you reach the end of the switch without having picked a case, that we generate an exception and throw it. Great question. I want to show you something cool, which is this helper method down here. It's an if else, if else, if else, to pick the right value of an enum describing what time of day. And if I click on it, somewhere near the top here, I have now an option to refactor it and convert it to a switch expression. And that's a switch expression that uses the relational patterns here. So I can actually now have this expressed as a beautiful switch expression as well. Of course, you could now go on and inline this local variable, and then you can make the whole method expression based and all that if you want to go all out on the tersing it up. This is also, by the way, this is an option for using the OR. If I want to demonstrate the OR, we could, because you see there's an overnight time band both at the beginning of the day and at the end of the day. So that's a time period that overlaps midnight. So we could say OR greater than or equal to 20, and now the first case here covers the whole night period in one pattern. And we get it. You see, there's a red squiggly on the underscore here because now we can never reach the end. So that would be another way of describing it. I actually think the other one was nicer. The old one was nicer, but just to show the OR pattern in action. So that's it for patterns in C#9. And with that, that's also it for me doing code live here. So let's go back to slides and talk about a few other features. But keep the questions coming. So there are many more features in C#9. I'll just tell you about two more quickly. One is what we call target type new. So when you write a new expression, you can now leave out the type. You don't have to say new person here. You can just say new when there is a target type. And what we mean by target type is that there's a type that you are clearly being converted to. So by assignment, by being passed to a parameter, that kind of stuff. Then we'll just look at that type and stick it in where the green spot is here, and see if that works out. That's roughly how this works. Is there a target type? Does it work when we put it in? If so, then congratulations, your target typing was successful. So you might not think it's very useful here because it doesn't save you a lot of keystrokes or whatever. But there are definitely situations where this is nice. You know, think about initializing a large array in code, and you have to new up the element type of the array again and again and again. Maybe the type that you're newing up is a big generic type. It's nice in those cases where the target type is obvious to just be able to leave it out in sort of repetitive cases. There's now a question, why would you use it over var? Well, in this example, there's no good reason to use one or the other. It's more when the var only works for this particular example where you're actually declaring a new variable. But in many cases, that's not what you're doing with your expression. You're passing it to something existing. You're assigning it to an existing variable, or you're passing it to a method that has an existing parameter type there. You can't use var for that scenario. If you want to save something, it has to be in the expression itself. So that's why. var is a special case where it's a wash. It doesn't matter much which one you use. Another nifty feature, covariant returns, which lets you, when you override a virtual method, it lets you actually tighten the return type to something more specific. As long as it's more specific than the previous override, then you're fine. So if you know that this overridden method will always return a student, then go ahead and make use of that fact. You know, you can now express it in code. It will be enforced in the body, and it can be exploited by the caller if they know that they're calling this override and not, if they're specific enough that they know that. Right. There's a question here regarding primary constructors. Is there a way to get rid of the plumbing for fields, typically in a DI scenario? That's good. So actually, let's go beyond C#, and let's start by clicking away to where I talk about the primary constructors. So we'll skip this for a bit, and we can come back to it. Here we go. Here's an example of primary constructors. The idea of primary constructors in general is that the parameters are in scope throughout the class. This is a simple example where I'm only using them for initialization. So we don't have to store them and keep them around. But if you use the parameters even inside of a method body, for instance, then we will do the work to store the contents of those parameters inside of the object. We'll generate private fields, essentially, and they will stay in scope and stay available throughout the lifetime of the object. So that means that for situations like a dependency injection, for instance, which is what you're referring to, Morten, you don't have to declare fields to store them in. You can just take them as parameters to your primary constructor, take those dependencies, and you can just use them throughout the object. And that's all you have to do. So if I understand your question correctly, then this addresses it. And in fact, there's a lot of DI around in some of our own frameworks and other people's, and we had that. We had DI, dependency injection, as a specific scenario that we discussed here to make sure that was helped by it. So hopefully that works for you. Yeah, so I already mentioned primary constructors. Other than that, but if you want, there are certain other things that we want to do better in beyond C#9 that are in the same space as the record stuff, and I think we can spend a little time going through that, and that's probably where the time runs out. But let's see, depending on the volume of questions at the end, maybe we can sneak a peek at the other stuff. But quickly, one of the things that we have the init-only properties here that will often be used in a record or class that is otherwise fairly short. Like you will tend, sometimes you just want to describe your data model as tersely as possible, and here it might be a little much to declare these individual properties with this much fanfare. And so we're thinking about taking public init-only auto properties and allowing you to abbreviate them to data properties. This is something we're actually discussing in language design meeting tomorrow, so this might change, but this is, as of today, this is how we're thinking of it. But we haven't really hashed it out yet. And it's simply a shorthand for what you saw before. It just becomes this, but it now becomes short enough that it really does make for one-liners. And one of the reasons why we're interested in this is, well, that's nice, but it also, the primary constructor thing in records that also produces public members, that's almost too attractive in a way, and it'll make you use constructors when you don't really want to, or when you don't really have to, just because your declarations are shorter. And so we kind of want to provide an also quite short way of declaring classes or records that don't have primary constructors, or records in particular that don't have primary constructors. So that's the reason why we're considering this abbreviation. Let's skip this. Let's skip this one actually. Final initializers. One of the other downsides of using object initializers is that you don't. When you're using a constructor, the constructor can validate the final state of the object, right? And say, okay, now let me just check that everything's okay, and then I'm done. Otherwise, I'll throw some exceptions. When you make use of object initializers, that's not really a good place for, and anyone can make use of object initializers, right? But that means you don't really get a you don't have a good place to do final validation or finally sort of nip and tuck and fix things up after you got all the initialization input. So we're thinking about adding another kind of member called an emitter, or a final initializer that maybe this is the syntax. We will still have to work on the syntax, but where inside of the body of the class, you can declare this final initializer that is code that is run at the very last moment after all the object initializers, sort of at the end curly here. We run this code, throw in exceptions that it might give on validation, and execute any changes it might do to the object. It still has access to mutate read-only fields and so on, just like the emitters do. And then after that is done, the object is considered completely initialized, and the door closes to emitters and read-only fields. Okay, so that's something we're considering. This one here, parameter null checks. Here I'm doing it in a constructor just to be able to use the same example from slide to slide. But in general, in parameter lists, you know, we did all this work in C#8 to help you track nullability. But oftentimes, even if you have non-nullable parameters, your callers might still pass you null, right? They might ignore the warnings they get, or they might have them turned off or whatever. So oftentimes you still want to check for null, even when you're telling them, I don't want nulls, you still want to check. But that's laborious code to write, you know, throw new argument, null exception, blah, blah, blah. So we're thinking to allow you to just put 2 exclamation marks after the parameter, and that means check that this is not null and throw if it is. So parameter null checks. There you go. Oh, and then we have to figure out what records mean for structs. Today, they're always classes. In C#9, they're always classes. In C#10, you'll be able to say struct record or record struct. We're still talking about that. That's also on the agenda for tomorrow. And then many things about records are already the case in structs. Like they already have value equality. They already have a way of copying themselves. So what we're thinking is that struct records, probably all structs will be able to be used in a with expression, regardless of whether they're declared as records. But there are other things that you get from declaring them as records, like implementation of an equals equals operator and so on. And that's it for the struct record. That's it for sort of the record part of the future, if you will. So I'm looking up to see if there are any questions, because we're now in the Q&A period.
Yeah, so feel free to ask Mads any questions you have. And while we're waiting for you to type it in, I have one of my own, actually.
Great.
So if you had to pick just one thing, what is your favorite new feature in C#9?
I actually think it's the init only properties, the init accessors. I think it solves a very long-standing problem in a very small way. It's a very small language feature that does a lot. Like it finally allows object initializers and immutability to come together. Both have become popular in the C# world, and they've been kept separate for all this time. And just with that little feature, now they fit neatly together. That I like how that just does a lot of work for very little cost, so to speak.
Right.
So that was actually somebody else just asked that same question.
Yeah,
same
great
answer.
minds think alike.
Yeah.
Yeah. So maybe Håkon has some new questions. If not, I have one more.
Okay, yeah, go for it.
Yeah. So how does F# influence the design of C#?
It influences it in a F# is a functional first kind of programming language, and we are every feature of C# adds something that was inspired by functional programming, and F# is our go-to functional programming language. So it's definitely where we get the most experience with functional features. So in that sense, it's a big inspiration. Now, when we do get inspired by functional features, we can't just take them from F# or somewhere else and just put them in. As I said in the beginning, we want to make sure that they fit well with an object-oriented sort of baseline. And records are a case in point where we wanted to make sure that records were, that they worked well with inheritance. One of the biggest inhibitors for us, we've talked about records for probably at least almost a decade for C#. And what finally made us be able to do them was we figured out how to do them in a way that respects inheritance. Figuring out the value-based equality for inheritance and so on, the with expressions working in the light of inheritance. That was sort of the big corner for us to turn, which is something that functional languages generally don't have to really worry about. Their records are much simpler, and they don't have inheritance for records.
All right. We have another question. Do you want to read it?
Do you think you'll ever deprecate, remove a feature from the language, and if so, which? I don't think we will, though I wish we would. I mean, it's a fundamental problem of programming language design that once you put a feature in, people will use it. And so if you remove it again, then all the code where they use it will be broken. And we don't want to do that. So the current plan is never to deprecate a feature. Now, there are occasionally features that I wish we could deprecate or go back and do differently. I have a couple of favorites, least favorite features. One of them is the way that the delegate language feature, I actually think is a terrible kind of Frankenstein crossbreed between function types and collection types. Like delegates are what we use as a type of functions, but they're also collections in the sense that you can add them together and then you get a delegate. That's all the functions getting called one after each other. And that's just like, how is that a basic language feature? That was a mistake. It fit well with the event paradigm at the time, but it hasn't stood the test of time. I wish we could go back and change something there. What's your least favorite feature in C#9? They haven't been around for long enough for me to. If there was one I didn't like, we would yank it out. We haven't shipped yet. We only ship features that we really like. Rust seems to be gaining popularity even inside MS. What ideas from Rust do you think will inspire C#? So Rust, I think the core sort of value proposition of Rust is that it's not a garbage collected language, but it has a type system for tracking lifetimes. So you never get like dangling pointers or safety issues. That's probably not something we could take into C#, I think, at this point. There are some parts of the analysis that become similar to things we do about tracking refs and spans and things about some of the things we've added about ref structs and so on, that we get into similar kinds of lifetime analysis. So there's some like overlap there. When it comes to actual features, one thing that is nice in Rust that not many languages have is that in Rust, you can sort of do the equivalent of implementing an interface, just like in C#, like this class implements this interface, where you declare the class. But you can actually also do it where you declare the interface. So you could instead say, so you have the class already declared, and when you declare the interface, you can say, oh, by the way, that class implements this new interface. So you have sort of more options about where you create the strong coupling between the class and the interface. Now, I don't think we will do that directly in C#, but one thing that we're looking at I don't have time to go into today, but is for the potential future is mechanisms where you can completely decouple the class and the interface by even declaring in a third place, like in a third piece of code, that class that already exists implements that interface that already exists. And here's how it does it. So there's some similar trying to get flexibility and decoupling for like software engineering purposes. It's where they took some steps there that are interesting, and that's one of the inspirations that we're looking at for something we might do there in the future. All right.
So I think we've reached the end there of this interesting presentation. So we want to thank you, Matt, so much for tuning in and having this thing for us. It's really, really valuable. So I can say we have had record attendance here.
That's good since we talked about records, right? Well, it's been great to be here. Thanks for the opportunity.
Yeah, I guess we can actually take one last question here.
One just came in. Yes. Can you give us more details about how do you balance aggressively innovating and evolving C# and considerations for weight and complexity of C#? Well, that's a great question. That's sort of on our minds all the time. One of our favorite quotes from when Anders was still on the C# design team is every feature comes in at minus 100 points, meaning that we have to be really diligent about whether we add a feature and how we add a feature, right? So even though we want to do what we need to do to be a good language, and we want to lean into that, we don't want to do something that isn't worth it, right? Because as I said, we never throw out a language feature. We have to want to wake up next to it 20 years from now. We are married to each language feature forever. And so we try to think hard about making both, is this feature valuable at all, but also how can we make it so that it is as valuable as possible, like applies to as many scenarios as possible, and has as little impact as possible in the language. Like if we can do a lot of things with a single keyword and without like upsetting the balance of the language much, then we'll try to do that. And that's often the majority of language design is how can we get it so that the syntactic weight, the conceptual weight of the feature is as little as possible. You see some, insanely big and impactful features like async. They're really, from a syntactic standpoint, they're very lightweight, right? You have an async modifier on members, and you have an await keyword in your expressions, and that's it, right, from a syntax point of view. And that's a result of like trying to massage the feature so that it has as little cost as possible in the language. But it's difficult, and one day, we might sort of die a heat death of we get too much, we accumulate too much stuff in the language, and it becomes too hard to evolve and too hard to use, too hard to learn. That's a real risk, and we're just willing to take that risk. The alternative is to become a legacy language and not be useful for your new projects anymore. And we don't want to be that either. So we're probably more likely to die of too many features than of too few. But that's a choice we made. We try to stay alive as long as possible by adding the features in a way that has that advances us as little as possible towards that heat death. But eventually that might happen. Or something might happen that requires such fundamental changes that C# just can't make the change, right? Or our current generation of programming languages can't follow along. Something big needs to be handled that just needs us all to do logic programming or something like that. And we just, all the existing languages are just, we just all instantly became legacy there. Sorry about that. Now we have to go and innovate again. And now, that's a risk. We'll see.
Okay. So once again, thank you so much, Mads, for participating.
Thanks. This was great.
I also want to thank all of you listeners or viewers here that's been tuning in on YouTube and on Twitch. And also please do subscribe so that you don't miss out when we go live next time. And we will also announce the winner on Twitter for the best question here in a couple of days. So thank you so much once again, and then we'll see you next time.